Hello. Today I will show you our software for structure analysis, which is made as an internet application. So first I'm going to talk a little bit about the technical background, how the program is being run on your computer. Then I'm going to use that software to solve an example from a textbook. And finally, I'm going to alter the solved model to show some more advanced features. Well, that's the software itself. Maybe you can recognize that there is no need to install the software into your computer. Actually, it is not possible. The program is being run from your internet browser, so it is a web page, which also brings the important advantage that you can use any platform, for example, Apple Macintosh, Microsoft Windows, Linux, also Android or iPad. There are some requirements on your internet browser. The requirement is that browser has to have support of SVG format. At the time being, all major browsers on the market, they do support this SVG format. The calculations and all important operations are being done by JavaScript. Once the web page is open, you no longer need internet connection. Now I want to solve this frame from the textbook. The textbook provides also solution, which will be useful later. So the frame is of 12 meters height. The span is 8 meters. So I will make this example from scratch. You will see the network of grid lines. On the top, this is your working area. On the top, from 0 to roughly 26. On the left, from 0 to 24. You can alter the size of working area in settings. There are two fields to change the working area. You can also change from metric units to imperial units. So now how to draw or how to enter the structure. I will enter the structure directly beam by beam. So let's start with top beam. Now I am going to use pointer. In your case, it may be also a finger if you have touch screen. So I will draw beam from here. Let's check. Let's focus on this field and the second field. So now 8 meters as required. Then we have to go 12 meters down. 12 indeed. The part is finished, so I will escape by pressing escape key from my keyboard. Escape. And let's draw the left beam or left column. So again, I have to go 12 meters down. I will not use pointer, I will rather type the coordinates 0, 12, enter, escape. Well, that's pretty simple. Next step, to enter the fixed supports. So I am going to point to the left node, to the right node. The supports are complete already. We will talk a little bit about load. Let's place some lateral load. That means I have to enter 90 degrees. and we will observe how to modify the load or how to delete the load. For example, I made a mistake, 2 kilonewtons in here, or I don't want. So if I click on the load, then I may press remove button. It is gone, or I may use remove button from the toolbar. That's for case if you have a touch screen. If you don't have touch screen, it may be more convenient just to press delete from your keyboard. What if I want to change the magnitude of this load? Then I will change from 2 to 4. I may also move the load to the top. At the moment, the load is placed 6 meters from the top, from this node, the red one. I will place it to 2 meters from the node. So I hope that you can recognize that it's pretty simple. What about linear load? Let's start with linear, continuous, constant load, because that's maybe 95% of cases. So I will enter 10 kilonewtons per meter. And now again, I just point on the beam and the load is entered. Delete. But let's go back to our example. We have to enter from 0 to 24. So I will choose loads, linear, from 0 to 24. And from 0 to 24 again. And the example has been entered. So it is a good idea to save my progress. What I did now, I did save into the browser. There are no data sent to some server. Everything is stored inside your web browser. You probably want to see the results, so I will solve the structure. And let's go directly to moment diagram. So I am going to call diagrams, moment diagram. Maybe you are used to use reversed convention, and I am going to hide loads and reactions. Now we may compare the results with results from the textbook. And if you compare the results, you will realize that the results do fit. In the next step, I want to modify this structure, because so far we didn't enter, for example, cross-section. We don't have proper cross-section, so we may investigate deflections or deformations, but it doesn't make much sense if we didn't enter cross-sections. So I will, for the time being, I will pretend that our structure is steel structure, that I want to enter 2 braces from one corner to support, from the left corner, from the right corner to the left support. I will have 2 braces, and I will assign sections to each beam, to each member of our structure. So first, how to make braces. I will use the pointer again. One brace is finished. Now I want to continue from different points, so I have to interrupt the action. I will call escape. If you have touch screen, you want to call either this cross or abort. And the other brace. Now I got a warning. This warning is pretty important. Beams intersect not in a node. It does say that here is an intersection, but there is no interaction. Those beams or braces, they just cross each other with no interaction. I decided that it is not what I want, so I will modify the design. Now the beams, they are connected in this node. So I will finish the model. I have two braces. Actually, I have 4 braces connected in the center and into the corners. Since it is still design structure, it is very likely that those braces, they are connected into hinge, that this support has to be pinned. So I have to call hinge from the toolbar, and now I can point to each beam and specify that here is connection to hinge, the same in here, but it is somehow annoying to pick up beam by beam, so I will rather use this bulk mode. Now I'm going to select all braces, and I will run the command on 4 braces at one time. So it's finished. Escape, escape, escape. So what is missing? I still don't have any cross-section assigned. So I have to specify, I have to provide some sections. According to my proposal, I will use IPE 180 for column, this profile, IPE 180. So it will be my column section with cross-section area of 23.9, moment of inertia 1320. It is steel design structure, and for structural analysis we usually do not work with shear area. In practice you may want to involve the effect of shear, and in that case you will enter proper shear area also. So one section has been created. Then for beam I will use the values which I prepared in advance. And finally brace. So the sections, they have been created, but they are still not assigned. So I will select, for example, columns, and then I want to assign column, I want to assign the proper section. Assign it already. Now I will press escape. If you use touchscreen, you don't have escape on keyboard because you don't have keyboard, so you will use this button from the toolbar, abort. And I will continue with beam. Apply. Again, abort. And lastly, let's select braces. And let's assign braces. So let's check deformations or let's observe the deflected shape. You may use pointer at some points of the deflected shape to read the deflections. So at this point, the first number is in x direction, the second number is y direction. So that means that this point has been moved 8 centimeters to the right and roughly almost 1 millimeter down. Let's call moments again, moment diagram. I will switch off loads and reaction. So again, I can use pointer to observe value at any point. Not any, but at some important points. You may also see that the braces, they are really only under axial force. There is no moment, no shear force, only normal force. So that's it, and I hope that you will find this software useful.